Right. Uh, Good morning, my dear students. Welcome to this session on cables and suspension bridges, Unit 3 of your syllabus. Last session we have uh, proved the theorem, general cable theorem, which is namely I have written the theorem in mathematical form so that you know very well. So M at any location on the beam is equal to horizontal cable tension at the same point on the cable multiplied by the vertical distance between that point and the line joining the supports of the cable. This is what is a theorem. So h into y, h is nothing but this horizontal component is written as h. Okay. So h into y is equal to moment at the same location x for simply supported beam, which is imaginary. Right. So this is what is proved in the last session. Right. Proceeding further. So it is now to enter into the analysis part. So cable subjected to concentrated loads. How we are able to solve the cables subjected to concentrated loads. Okay, so let us see that. Uh, right, so just we will see these first two statements, then we will move on to the analysis parts. Again, just a repetition to characterize the cable once again, right? So cables are considered to be perfectly flexible, right, and inextensible. Okay, we assume them that they are inextensible, right? So as they're flexible, they can't resist shear force and bending moment. They can only take the axial tension. Okay, so that's the important characteristics of the cable, right? So and that cable tension always acts tangential to the cable at any point along the length, right? So this is already we have talked about these characteristics, right? If the weight of the cable is negligible as compared with the externally applied loads, then self weight is neglected in the analysis, because we are proceeding to analysis, so we need some assumptions, right? So these are the things that we are considering for the present analysis. Okay, so cable can take only axial tension, that is first one, and then self weight of the cable is neglected. Okay, so let us see how you analyze the cable. Means what? Finding internal and external reactions. Okay, so how you analyze the cable when it is subjected to point loads, right? So I will come back to this PowerPoint presentation, right, by showing you with some example here. So let us just draw one cable just to show you how this analysis is going to be. Okay, draw another support. So right, and this is the cable, and before you load it, so it is going to be some curvature, right? So once you apply the load on this, right, what happens? So this is the line joining of the supports. Okay, so let me just right now Okay, so what happens when the load, this is horizontal line, right? So what happens, this loaded point will be deflecting downwards, and this point will move down, and right, this is going to become like this, and something, right? So then what, where is the load now? Here is the load now. Okay, load also moves along with the cable. Okay, so what happens? So the cable which is curved before you load it now has become a now two straight lines. The cable has become two straight lines. Let us imagine this is A. Let's take this as B. Let me say this is C. Okay, right. This is something like L by 2. Imagine, just assume that there the point load is at midpoint. Okay, now let us just list out how many unknowns you have. So A is a hinge. So I have HA, VA, two unknowns. B is also hinge. So I'll have two unknowns, HB, VB. So four external reactions, right? Then tension in portion AC. Okay, and tension in portion BC, right? Tensile force, right? Okay, so portion AC and portion BC, there are two portions where from A to C tension is constant, and also from B to C tension is constant. So total we have six unknowns. Okay, so internal four unknowns, and the two unknowns, external four unknowns and internal two unknowns. Right. So how do you solve these six plus also? Right. What about this now geometry, unknown geometry, where the dip, what you call is dip value y. So y. Okay. So total 6 plus 1, 6 force unknowns, one geometrical unknown. So total 7 unknowns. Right. Now to solve 7 unknowns, you need 7 equations. So what are they? So joint A, let us check joint A, just like you solve a truss. So joint A, you can apply two equilibrium equations. Joint B, you can apply two equilibrium equations. Similarly, joint C, you can apply two equilibrium equations. So you have got 6 equilibrium equations, whereas 7 unknowns are there. So what you need, plus one extra equation or a relation or some condition, something like that. So what this will be? This will be some condition on or a relation or a value on geometry. Okay. So this is how your problem will be. The cable analysis will be like this. So now you are able to solve 7 unknowns with 7 equations. So this is the simplest of all the problems, that we have taken a cable with one single point load, and how many you are getting? 7 unknowns, and you need 7 equations, for which 6 equilibrium equations are possible and plus 1 geometry relation, something like now length of the cable is so much, okay, and or else y value will be given to you, something like that. Anything can be possible, okay. So that is how you are able to solve this one. Say if the span of the L is given, okay, and similarly the total length of the cable is given. For example, S. If you say S is the length of the cable, so S means what? Length of AC plus BC. So S by 2 will become, for as this is symmetry, length of AC is S by 2. So you know AC value and you know this till midpoint, the half of this span L by 2. So you can find this angle or you can find Y. Okay. So square root of AC square minus this L by 2 whole square. That will give you Y value. So likewise, so some geometry, some known values will be given to you, so that your additional relation you are able to develop based on that, the additional equation that is required. Remaining all are equilibrium equations that must be solved. Okay. So let us try one more example. Okay. So let me take one new. So empty form I have taken. Now let's proceed with two such point loads. What happens? Let us see. So hinge is provided at one end, the other end also. Let us have one hinge, and when the loads are not there, cable is just like that. So let us apply some load at 1/3 or 1/4, whatever it is. Let it be some P1, let it be some P2. Okay. So now let's draw the card line joining the supports, and then so once you apply the loads, this point comes down. Also this point comes down. Imagine, say for example, for this case, so if the loads are same, P1 equal to P2, then these deflections will be same. So now you join all this cable profile for, so now this will be the cable profile. So the loads also comes down. So now this is the position of P1, it's the position of P2 where P1 is equal to P2. That's why it is possible. Otherwise, if P1 is not equal to P2, then the trapezoid will be some uneven deformations. Okay. So right. So this, for example, if you say Y1, this total dip. So for example, is A, B, then C, and D. So YC I call Y at C. This is, let us say, Y at D. Okay. So now you estimate unknowns and estimate equations. Analysis is like the how many unknowns you have and how many equations you have. How do you plan for analysis? This is what you need. So prior to solve a problem, you have to plan yourself. So unknowns, let us find out. So two external reactions at one end, another two external reactions at the other end. Okay, done. Then there are three cable portions AC, CD, BD. The three cable portions, so three tensile values, tension values in each portion. Portion AC, one tension value, portion CD, one tension value, portion BD, another tension value. So three here. So this is four external and three internal. Along with that, there are two geometric unknowns, YC unknown and YD unknown. Two geometric unknowns. So total how many? 4 plus 3. 7 plus 2. Total 9 unknowns. Okay. Now let us estimate the equations. These are unknowns. 1, 2, this is one joint, joint number 2, joint number 3, joint number 4. So 4 joints. Each joint has got two equilibrium equations. So hence what you have? 8 equilibrium equations. So one additional relation or one additional equation or one condition should be given to you in the form of geometry. Then it will be 9 equations to solve. Okay, so 9 unknowns, 9 equations. So this is how we plan uh, for analysis. So what you need to do step by step for proceeding to analysis. Same here. See, take joint A, write the equilibrium equations, then proceed to the next joint, proceed to the next joint, and then proceed to the next joint. Likewise. Okay. So this way you can understand how the analysis of cables can be taken up when point loads are applied. Okay. So let us see now with what you have here. Right. So here it is another example taken with some so many point loads. Okay. That is what is given here. So it is some cable having so many point loads. Say there are 3 point loads taken: P1, P2, P3, and two different elevations. So what is here is, so 4 reaction components. Unknowns are now counting here. You are counting the unknowns. So 2 here. It looks like the rigid support, but it is not. Okay, because the cable cannot resist bending. You cannot expect moment reaction. Remember. So same here. Here also, it looks like it is a fixed support, but the cable cannot not take or cannot produce resistance to bending. That's why if there should be a moment reaction, the cable shall be now tangent to this horizontal line. Then only you expect a moment reaction. Okay. So as there is no moment reaction, cable deflected down to a stable shape. Okay. So 2 reactions here. So 2 and 2. Total 4 reaction components. Cable tensions in each 4 segments. There are 4 segments: AC, CD, DE, EB. 1, 2, 3, 4 segments. So that's why 4 tensile values, 4 tension values, and 3 sag values, geometric unknowns. Sag at C, and this is 0, right? And sag at D, sag at E. Okay, so this is where the load is available. So 3 sag values. So total 4 plus 4 plus 3, 11 unknowns. So what you need? 11 equations. So you have to count now the equilibrium equation. So we can write two force equilibrium equations at each of the joints A, B, C, D and E. So total 5 into 10, 5 into 2, 10 equations. And one more equation is always required. So that is from geometry of the cable. Okay. So this geometry of the cable. Okay. Right. So that's how we plan for the analysis. Okay. So that is what is shown here, right? This is uh, about how you plan for analysis when you have point loads on the cable. Okay, so this is all about it. So next session we will see one example. Okay, right. Thank you.